welcome, good afternoon. Last session of the day. How the heck do you profile a live game? As a disclaimer, this is one way to do it. It's not the only way. And hopefully you get inspired. You could pick and choose whatever it works for your certain situation, game, style, genre. I'm Luis. I'm a senior developer in Voodoo. I've been working in games for 15 years or so. And yeah, it's a pleasure to be here.
Hi, my name is Moritz. I'm the principal engineer for the SDK, which is basically the base building blocks for all the games that we have. We support features that every live game needs, such as live ops, ads, monetization, tooling, and basically CI/CD automation. So everything that the game needs, that's the SDK that we provide. And as we have a packed agenda today, we want to tell a little story. So as we're developing features in the live game, we want first to let you know what a live game is, what's the challenges that we face, what is the scope that we have. Then we will go into development phase. So we will present you ways that you can customize your profiler to the needs that your features require. So you can basically get your correct KPIs, your vitals, et cetera, and then we go into the health metric, which is basically you have your feature, you press the rollout button, you expect that everything works fine. And after that, you have to maintain your game. So you have your ongoing maintenance of the game, you have your ongoing health, so if you want to be profitable. Yes, your turn.
So first things first, let's put ourselves in context and the use case and whatever we're going to be working on today. What is a live game? What is a live game? What makes it so special? So let's start from the beginning. So we're working here in Voodoo. These are more or less the numbers from last year. 150 monthly active users, 8 billion downloads, millions of revenue. So live game, it's a game that is big. This is, of course, we're going to use one use case, which contributed to these numbers. It's not all these numbers from one game. This comes from a plethora of games. So yeah, we're going to work with Blockjam. This is the game that I'm currently developing. And yeah, let's understand a bit what do we mean by live game. So basically, it's a game that is in development. We're still creating features and deploying to the users. We do it by A/B testing, so it's very dynamic. Some users have some features, some users, they don't have it. We compare, we deploy. It has certain characteristics. There's a lot of fragmentations. We don't force update very often in these mobile games, so there's going to be plenty of versions of the game out there with plenty of iOS, and it has a very long tail. So we need to account for that, right? Not every user has the latest version, which has all the bug fixes and who knows what. There's also a lot of external dependencies. So yeah, ads, user acquisition, tracking, whatever we're using, it can also affect the stability of the live game. And yeah, we also work with this concept of immutable perception. These games, for us, it's very, very important that it's stable. As soon as we put a version that it's broken, it hangs, it crashes, we're pretty sure we're going to lose a bunch of users. So this is something that it's very important for us to not do. So we work with this concept of immutable perception. So yeah, basically, let's talk a bit about Blockjam 3D. This is how the game looks right now. But yeah, this is how it looked before. So yeah, it's a game that had performance issues, memory issues, CPU issues, and we went through a full visual revamp. We're still developing. We have added features, and things are gonna go wrong, right? None of these. Well, in my experience, none of this goes smooth, and you need a way to handle this, right? And basically, If everything is on fire, one of the techniques that we do is, okay, let's prioritize the top things that are on fire. These are the ones that we're going to fix. Normally, you don't have the resources to fix everything. So it's important to keep calm, keep testing the game, keep making a better product for the users. So yeah, this is an example feature that we added recently, the Dragon Challenge. Basically a brand new game mode. Of course, reusing some of the mechanics that is already there, but yeah, total visual revamp, like more assets, more stages, more levels, more variety in all kind of, yeah, all over the game. And yeah, basically the game needs to work with this and without this, so we can actually test and validate that this feature is actually doing the target KPIs that we are targeting. For example, if we hope that this feature will increase, I don't know, the in-app purchases, then this is what we will compare, and this is what will set that the feature was successful or not. Otherwise, we can analyze and iterate. So yeah, and by example, a feature like this, normally for us in developer time, it would be something like 1 month, just in comparison to see more or less what is our speed in developing in this kind of game. And yeah, one of the key things for a live game is that you cannot solve everything. And it doesn't matter if everything is on fire, it doesn't matter that all the data, all the KPIs are in the floor. Somebody said, this is something that we use, basically we cannot fix something that it doesn't have a solution. And sometimes, I mean, you get all this feedback that, oh my God, I cannot play the game, do we need to fix this? And then it's like, okay, but how do you want to fix it? And then all the departments, they want a different solution. And it's like, okay, I cannot fix it. You first need to go and have your meeting, whatever, and agree in a solution, and then we can fix it. So then there's no problem. The problem is, please find a solution first. So this is just advice of, hey, yeah, you're working in a live game. The live game needs to be stable, but there's some things that they cannot be fixed right away, right? They need some maturity, let's say, to actually find a better solution for all the stakeholders.
So yeah, so you want to start your feature, you're developing. Let's try to see what can we do with the profile itself. But first, I want to step back, and every time you use the profiler, you're optimizing piece. Please have these 3 principles in mind. Before you start anything, create yourself a baseline. Like you have to know where you start. Afterwards, while you're developing, you have to have that baseline always in mind. So you do not degrade anything. You do not basically crush your game. So the feature development is going well. And after that, you profile again and you ensure that actually what you've done is what you expected in the first place. So this applies to a lot of ways of working, but profiling and optimization is one special one. So we wanted to focus on the Unity profiler because you all have access to it, and we don't want to mess with a paid tool, so this is far easier. So we have a quick revamp of what are profiler markers, what are counters, what are recorders, and what are profiler modules. Please install the Unity profiling core API because it comes with a lot of helpy tools. So a profiler marker. Basically, a profiler marker is a mark in your code that you can use to instrument your code itself. You can use it to instrument bottlenecks, to instrument basically time of your code execution. But not only it's useful for your execution, your resource-intensive code blocks, it also helps you visualize your code. So as you see on the right side of the profile, you actually see where your code is, what's happening, in which part of the job it's happening. So let's start to creating something like a real AI. So we have a pathfinding algorithm that is very heavy and want to instrument it. So we basically create ourselves a profile marker. Keep in mind to use a good naming because it will be difficult to filter or find later. And once you have the profile marker, you just wrap your code within it. In this example, I've used the disposable scoping. So basically, it's automatically calling the begin and the end of the marker. This makes the code far easier to use, but keep in mind it has a downside, which is if you're doing a release build, this will not be completely out-compiled. So the begin and the end calls, they will be out-compiled, but not the disposable itself. So then what I like to do is I just write it this way, so I have it in the scope block itself. This will also not out-compile it, but what we can do is we can use IL waving. That's a rabbit hole if you want to go into, and you can actually inject that line of code into the functions that you like. So you could auto-generate your profile experience from the Unity editor, which is super good. So now how do we see the profiles? As you can see, our AI system is very intensive, and it's just a lock, so locks are very intensive too. But you see quickly where your markers are. On the downside, like on the upper, on the button, you see the timeline, the hierarchy, which is basically you have the timeline, you have the hierarchy, and the raw hierarchy. The difference between the hierarchy and the raw hierarchy is that the hierarchy view is basically grouped by stack trace. So if you want to dig deeper, recommendation, start with the hierarchy. If you need more info, go to the raw one. Then into counters. Counters are a bit different. They basically are there to track your metrics. So they can be counted, they can be summed. It's the number, basically, that you have. These normally appear on the upper side as a graph, but you can also draw them basically as a line, as a block graph. So these white blocks that you have. They can be inspected at runtime in development, and a lot of counters comes out of the box with Unity, which you can even see them in release builds. So let's add a counter for it. This time we are using the profiler API, and we are creating just a counter for ourselves, which is the profiler counter value. We use it that it counts, so Unity will automatically update it, and we ensure that it flushes automatically by the end of the frame, and it resets to 0. So each time we call it, we know that the value that we'll have in the profiler will be the exact number of pathfinding requests that we have. There is a raw structure for that, basically it's the profiler counter without the value, which gives you a lot more freedom to use, but it has not all the wiggles that comes off the box. And then we just update the counter, and that basically it is. So even now, you could just use your counter in a custom module. Keep in mind that your counters appear in that custom module window. You have to have one sample. So at least Unity have to sample once, and then you can use it. So this is very good if you like doing some quick profiling on stuff, yet you really don't want to commit to your repo or to your other colleagues. You just put something in, you validate your point, and you have it here. The downside is that this is local to your Unity editor. So you would have to use custom profiler modules to be able to share this between your peers. Now, the profiler recorder. So this is the third part of the profiling customization toolkit, which is basically it lets you read profile counters in runtime. This is especially valuable when you have a development build and you want to test and you don't have a Unity basically editor available to see that. You could basically read those profiler values and put them on top of your UI, on your screen, or you can even send them to your analytics backends. Some of the recorders are also available in release builds. One example is the frame time recorder. So if you're doing frame time recording and analytics, you can use that actually to send that to your backend. So we just create a profiler recorder, which is very easy. We have a mono behavior, so on enable, on disable. So we just start the recorder and we stop it. Stopping it, we call the dispose, which is very important to that you know when you start and you stop the recorder because it is very resource intensive. And on the update method, we just send the analytics, so that the frame time or whatever we have to our analytics backend. So on to profiler models. This basically is an example profiler module that ships with Unity. It is available project-wide. So if you create your own profilers, you can basically have that same customization for all your peers or for the project itself. You can have custom stuff and you can have custom visualization down there. So we want to bring you a quick giveaway. So let's just write a custom profiler module. So the profiler that we want to write is an HTTP profiler. So everybody here, I think, has some HTTP requests that you want to see how they are going, and you want to see them in the device itself. So we will check the in-flight requests, the succeeded requests, and the failed requests. Then we go into like one panel that gives us a bit of an accumulated stats view over the session itself, with the total number of requests, the session, the success rate, the error rate. And down there, we will try to modify the profiler and send special metadata from the runtime to the profile itself. So we can inject, for example, the URL or the stack trace where someone called that web request, which sometimes is very important if you have a web request that failed and you don't know from where in your code it was actually called. You can add the data that you like. This is just for this purpose of the talk. So starting with your runtime part of the profiler. So you have to create basically the category, which is that you can find your runtime profile and you see it in the editor itself. Then we create the counter. This time, as you can see, we will not basically reset it automatically and we will not submit it automatically because we want to do that by ourselves with all the data that we have. So we don't have inconsistencies between frames when we instrument stuff. And we send just the succeed and the failed request, which are basically, we are not sending them, but they will reset automatically to 0. We will not reset automatically to 0 the requests counter because we want a straight line in the profiler. We don't want that peaks all over the place. We want one line and that's it. So to track your web request, and this time we're using Unity Web Request async operation. We hook us into the operation, and the idea is that we just create an abstraction layer on the web request itself. The key part here is that we generate the UID for every web request that we make. This means that we're not using the URL as the key, we generate the UID. This means that we can track different in-flight requests to the same URL, and we will not override anything. This is also important later because they could come from different threads. So if we're using a concurrent dictionary to key stuff, we have a unique ID, and we ensure that we are not creating duplicates. And then we just hook us into the operation. We see if it's done, if it's not done, and we complete it. And now, how do we submit these data? So we basically use the late update. It's very important that you use the late update because then you can accumulate every action that you have in your update and just submit it once. It is very simple. We just have the request frame data. Request frame data, we will come into later into that. That's something specific from the addressable profiler suite, but not yet. And we basically just check if it's completed, if it's not completed, and we edit. On the late update also, we just check the last frame. So we're comparing between two frames. What happened the last frame to the rec request, and what's the state now? And this is the way that we decide is a success or a succeed. So if the status doesn't change, it's still in flight. If it changed, there can only be two options. It failed or succeeded. And then after that, we basically handle the completion, and we handle the request counter. And the important bit is here that we sample everything together in the same time. And we do a bit of cleanup. So let's go into the editor part of things. So now we have written our runtime part. We have to go into our editor part. So we try to create the editor module. It's very simple. You just have to use two attributes, what is the serializer attributes and the profiler module metadata. The serializer attributes is very important. So when you close and you open your profiler, it retains the same data. If you don't use it, you open, you close it, and everything is gone. So try to use it, even if it doesn't make any sense. It's very... You will have a hard way of finding out it's because of you missed an attribute. Then we basically define the profile itself, the counters that we want to use, that we want to reuse. And I just want to say that it's very important here that you name your counters properly. The counters itself, they're in Unity, they are basically in one list. So if you have a counter that is called requests, and you have a third-party tool that creates a counter that has also a counter that's called requests, you don't know which one you will be using. So try to make them unique. Then you just instruct the profiler module on how the counter should work. Again, here's the idea that we just provided in the counter itself. We're using the line graph. Here you can use the stacked graph that's on you, and we just enable the categories that we want. And the last part is that we say what's the class that will do the drawing part. I'm not showing you any part of the drawing part, but it's basically this simple, and you use UI Toolkit or whatever you like to draw it, including UMGI. UI Toolkit would be very easier to do that because it's fancier and it has a lot of tooling. So now we have our stats, we have the lines, everything is nice, and we want to have something session-wide. To have something session-wide, we have to accumulate stuff. But there is no update method in UI Toolkit. So really what we do, we're just running every 100 milliseconds a function that will try to accumulate and do the calculation. Also, there is a tricky thing in the profiler module that the user can just clear the data itself and everything is reset. So this can be achieved by you just inspect what's the last available frame and the last processed frame. So then you see that you have to reset all your profiling data. And the idea with accumulation is that while between those 100 milliseconds, a lot of frames could have passed, what you only have to do, if you have to see, you have to basically calculate what's the frames that you're missing that are pending. So this way, we just have the accumulated values and we go through it. So for each frame that is still pending, we get the raw frame data from the profile driver. The profile driver itself is what is the ingrained base class that you can use for all your profiling stuff. It comes with various methods to get the frame data, but I like to use the raw one because it gets you can access that raw data multiple times if you have more counters or more stuff that you need. If you use, for example, the simpler functions to just get an int from your frame internally, it will get the frame data, will dispose, and will get the frame data again, and then dispose again. So if you have to access more than one data point, just use this. It's far easier. And getting the data is quite similar. So you have your counter name, which results in a marker ID, and the marker ID then maps to the data itself, which in our case is an int value. So good. We have, again, the top one. We have the graph. Everything is nice. We have our panel. We have like the error rate. You know how everything is working, but you want to inspect like on frame what has actually happened in that frame. So then we want to have the stats for the current frame, and we want to have that nice request details. So to do that, it's very simple. In your view controller, you basically hook it into the selected frame index change. So every time the user selects an index, you get that callback back. Again, please dispose the stuff. The profiler is in native realm. Dispose everything, or you will have a very, very nasty memory leak. We ride back a bit to the runtime profiler. So to create this, what we do is we create a UID for the metadata. So every frame that you submit in the profiler has metadata itself. So it could have several metadata sections, basically, from several tools, from Unity tools, from your third-party integration that you have. So create yourself your unique metadata ID, and you can use it. And then you have the request ID, which is basically within your structure of metadata, you can assign different data types and structures within there. So for now, we just have one, so it's number 0. And that's it. And again, this is the data that we store for every frame. See it as a snapshot. The class itself, the profiler frame data, you can get that class directly from the addressable profiling suite. It is super easy. It's basically, as you understand it, it's a dictionary that then translates into a native array that you can send on your metadata. Just copy-paste that class. It needs 0 modification. So we want to submit something. As we said, we have a URL, an HTTP request. We have the URL. We have the stack trace. We might have a status, in progress, failed, or success. And we have the elapsed time. We could add like the size, the content size would be also useful, but just we stick with those 4. So that's not working. Why? Basically, the profiler set is a native land, so you have to use unmanaged types. String, unfortunately, is managed. So it tells us that we could use native arrays, which you actually can. But then with native arrays, you have to choose one of those beasts, with this, which basically is your allocator. There are only 2 valid allocators that we could use in this use case, which is the temporal one and the persistent one. The temporal allocator has the problem that it gets auto deallocated after the frame. So when we're submitting on our late update that goes into native frame, basically we already screwed up our information. So out of the box, we cannot use that. The persistent one does work. So we could actually see when we have to deallocate ourselves the data. But the problem is that we want to have a session view. So we could jump between actually frames within the session. So we actually do not know when to deallocate the information. So native array, nice, not the solution. But you have your Unity collections package. So it comes with a fixed string with various types. In this situation, we chose the 128 bytes for the URL and 512 bytes for the stack, 512 bytes for the stack, which should be enough. If you need more or less, do what you want. The only thing that you have to keep in mind is that these are fixed arrays. So your URL or your stack could be bigger than what you actually are allowed to allocate. So we have to truncate those. Truncation with Unicode is difficult, but the only thing that you need really is that you have every broken Unicode sequence, just replace it with a white space, and you're done. Like, I don't fucking care if it's a broken URL. If I see 60% of the URL, I think I'm good. But as you can see, we are not basically truncating 128 or 512. We are truncating 125 and 509. So that's 3 bytes less. That's because the Unity structures, they reserve 3 bytes to be able to basically work. And then, again, when we emit it, we just emit the frames, the frame metadata with the samples, the status, and the counter. So this means that everything works together. And to update our frame metrics now for each frame, it's as easy as just get the data, you present it, you get it from the frame. Again, we are reusing the raw frame data. Now it makes sense because we are basically accessing from the same frame data a lot of sections. And to get the frame metadata, you just use your UID and your request tags. So feed this into your UI, and you should have the result. And now I want to extend it a little bit because you can extend third-party tools. And one tool I really like to extend is the Xcode instruments. Xcode instruments has the upside that it works in release builds. So actually, you could do your marking, your profiler marking, and injection what is called signal posts into your release builds, which is cool for CPU profiling, but which is glorious for memory profiling. If you do memory profiling normally, you know that you have your memory snapshot. You know that you opened a pop-up or you loaded a level because the memory goes up. So you expect that around that time in your snapshot, the user actually clicked the button to open the level or to open the pop-up. But if you inject a signal post, you will have like a pin within your memory profiling that exactly tells when it happens. So sometimes it is really odd that it actually the memory goes up later or sooner. So it is very important to pinpoint that. And it's available at your fingerprint. It comes with Xcode, so if you're doing iOS builds, it's already there. The only difficult thing is that all the declarations are static and const in Objective-C, so you can just do a numbering, and then in the profile itself, you know that 0 means this, and 1 means this, and 2 means that, or you auto-generate with code generation if you like to, if you're fancy. And last but not least, the forgotten tools. How many of you have used those 3? 1, 2, cool. 3, nice. 4 is good. Okay, 5. Those are actually in all your Unity installations, so I don't know why we're not using it. The Unity data tool, well, apart from the Unity data tool, that's basically a GitHub repo. It allows you to generate an SQLite database from your asset bundle builds. So, which is super cool to be able to see your dependency chain. You see how the asset bundles are basically created, what depends on what's in there. And then we go into web extract and binary to text. Web extract is basically that compressed assets that you have in your release build. It decompresses those. And then you use binary to text, and it uses those decompressed assets, and it transforms it to a somehow readable, human-readable YAML file, which you get all the UIDs, then you then can pinpoint to your project. You get the preload tables and everything, how the asset bundle, for example, system works. And yeah, now on to Luis to hitting the rollout button.
So you got into that journey, you created this profiler, the game is live, what do we do? So I'm going to present here a bit of the things that we check normally, the key health metrics. So a little bit of what we do, at least in BlockJam, or rollout strategy. We normally release 1% in iOS and 30 in Android. And basically, we monitor the state of this release, right? We really want to see, basically, there's 3 outcomes of a rollout. Everything is fine, we don't see anything bad, then, okay, goes to everybody. There is some new errors, there's some things that we cannot reproduce. Then we wait more, we wait maybe 1 more day. And then there's the third option that is, hey, something is crashing, I don't know, people cannot open the game, something really bad, and then we stop the rollout, and then we create a hotfix. So yeah, basically for us, the key is monitoring a release. And we monitor a release. There's a lot of things that we check out. One of the most important is the Android vitals. Yeah, where you can check everything, and yeah, basically the famous orange line. You always need to be in the good threshold in Android. It's the best. It's the best because it will affect your user acquisition. It will, your visibility will get impacted. If you get really, really bad in the bad behavior threshold, even the users are gonna get a warning of, hey, this game is unstable. Are you sure you wanna use it? So, first thing, most important, is to be in the good side of the Android metrics. Then we use Firebase.
So apart from Android Vitals or any tool that we have, we want to present basically the use case with Firebase, which is a free tool. You can already use it. You can use Datadog. You can use Bugsnag. There are a lot of tools out there. But Firebase gives you what we really use, which is the release monitoring. So you have a quick health check of all your basic KPIs for your release. You can compare it to previous releases. You know what version is in. So you have a lot of stuff that you can see. What's it's very important is the top issues. So when something new comes out, a new top issues picks up, that's normally where you attack. And then the detailed crash view is also one very important thing. It gives you trends. Trends are very important in your game and when you release something because you know what is basically happening or what should happen. Like if you release something new that doesn't have any impact and the crash trend is going up, there's something that you didn't expect. The same when it's go down. There's something that you didn't expect, but that's positive, so we don't complain. But it normally doesn't happen anyway, anything. Plus, these tools give you more information, just Google Play. It gives you the traces, which you have that in the vitals too, but it also gives you keys, breadcrumbs, and more. It also has logs, so you can basically log error your stuff. So in the trace itself or in the crash, you could see your error logs or the method that you send. If, for example, you're tracking your ads statuses, for example, the loading of an ad, the watching of an ad, was the reward given and stuff like that. If you submit that to those tools too, you can see it. So sometimes you can cross-check this and see, okay, we know that that ad network is creating the crash because we know that in all the crashes that we saw it's the same ad network or it's even the same creative ID from an ad. So then you can basically do it directly. It also gives you information about the device itself, Unity version, your user ID if you submitted that with consent, please, and everything else that you want to check. And then we go into ANRs. I think everybody that is working on live games love ANRs. If there's something that hates it, nobody hates ANRs. We all love ANRs, I know. And there's one particular ANR that Google presents you this normally, and also on Firebase, which is, we have no idea what happened. You shouldn't dig into this. It doesn't matter. That's like that. Something happened in the last 6 seconds. But if you have tools that outline more information, you can actually hit into it. So please inspect your stack traces, inspect if there are matching logs between different threads. This, for example, is a log that we discovered in BlockJam from one of the ad networks, and it was droning, like it was basically increasing a lot of our ANRs, and we were able to debug and resolve that ANR because we knew which ad network it was. So it was actually quite nice to have. And then we go into the Unhandled exceptions. How many of you treat your unhandled exceptions with respect? Which I mean you care about them. 30%. Nice, nice. So I think unhandled exceptions, I think of them as the silent killer. Basically because if a crash happens, the user will just relaunch the application. Like, somewhere's broken, I just relaunch it, and it works. But if a user is presented with an unhandled exception, unhandled behavior, a choppy experience, something that is just breaking, or something is not progressing, they probably will rage quit and uninstall your game. So these, for me, are worse than crashes. So what you can do to these, first, consider them with respect. So unhandled exceptions go up. That's a code red for some of you. And we could introduce something like the stability score. The stability score comes inspired by Bugsnag. Bugsnag is a tool that has this score. So if you're using it, you already have it. But it's very simple. You can compute it yourself. It basically says, it gives you two metrics, which is the user stability and the session stability. So how many users without unheld exceptions do you have versus the total amount of users? And the same for the sessions. And this is just an example of how you can measure that. So you could check your own threshold. You could do your own threshold to be able to be in the goal section. You can see it as similar to a server uptime score. So if you have a server team, they normally have like an uptime score they have to measure. And if that uptime score goes down, they are in deep trouble, like job-wise and things like that. So I'm not saying that you should be in trouble too with that, but please keep it in mind that 90% stability score means that 1 out of 10 players is having unexpected behavior. That means if you're struggling with retention, 1 in 10 players could be drowning your retention, really. And for iOS, we haven't mentioned iOS itself. So we have Android Vitals, we have tools like Firebase, which is available for a lot of platforms, and we have the organizer. Again, how many of you use the Xcode organizer, really, like day-to-day basis? Oh, that's less than unheld exceptions. I'm curious. But it's basically on your fingerprint. If you have Xcode, you are working for iOS, use this. It is 2 clicks away, and you get a lot of information. You get the same information, sometimes even better than in the Android Vitals. One very cool thing is the regressions part, which, okay, I've not outlined, but there's a regressions tab and has lots of information about regressions and different metrics that could go bad. For example, loading times between the latest 5 version, I/O interactions, I/O processes like disk writes, or a lot of things. So please keep an eye on your metrics with this nice tool that you already have, and it's free. You already pay $99 a year for it. So if you're not using it, you're wasting that money. Luis?
So how do we get the stability score up? This is mostly common for everybody, but it's good to have it written down. It's like what we consider of, okay, this update is bad and we need to fix it. Basically, users cannot reach the game, there's a core gameplay issue, or users are not getting what they earned, right? Basically, if it affects deeply the user experience, for us, it's like, okay, we need to fix this, we need to do a hotfix, and this will increase the stability score. And also, one key thing that we do is that we really embrace our community. So we have open channels, and users can write us. And sometimes this is the fastest way to know that something is really bad. The users will find it for us. So we value this very deeply, and we embrace it. I'm gonna show you a bit the kind of things that we do monitoring these live releases and what do we use. So basically, it's very important for us, a very small set of important KPIs for us. And be mindful, every game has their own KPIs that you consider important. So it depends on the game, the genre, your priorities, and all this. We normally, frame rate, memory, battery, and thermal state for us is the most important ones. And we definitely recommend using the adaptive performance package so you can monitor all these things. Yeah, for frame rate, this is a bit of internal tools that we have. We basically calculate per scene how the game is doing. We can see in the graph, and we have like a measurement of what is a bad frame per minute. So basically, this is a fast way to know, okay, some parts of the game are not performing like we should. I mean, most common scenes, it makes sense when loading the game. So initialization and loading are the most common, but we can see here, for example, in this example, main menu has it's very high in bad and terrible frames. So this is just a key part of, oh, okay, this is a place where we can check it out and maybe we can optimize. Okay, yeah. Hello. Okay, woo! No, yeah, so we also have a more detailed graph on, okay, what is really, really good, what is normal, and what is really bad. So we make it by colors, and then we can see sometimes this is a good way to, okay, we have some bad frames in certain scenes. Let's check it out, what's happening. Let's do a more deeply investigation on that. So this it's a fast ways of getting started into investigating something that it might be bigger, right? The other thing that we do, of course, we compare with other games from Voodoo. I have checked them out. I mean, I don't want bad rep to any of the games, but we can see we normally compare with other games just to see, okay, how are we comparing with other games that are doing good or doing bad. So yeah, this makes a bit of a baseline of, okay, we're doing good, we're doing bad, we can do better, and all this. So we compare with our own portfolio. Very important for us, as I said before, we have a long tail of versions. So we compare per version. It could be that in this case is battery on the top and memory in the bottom. We compare per version to see maybe one version is actually doing really bad and it affects in certain aspect of the game. So this is more or less how we monitor new releases and compare with previous versions. Of course, super important for us, we A/B test. We even A/B test even more than we want. We are trying to set back, and some of the things that we really, really want in the game, we are not going to A/B test. We're going to put them there. It's just because this makes everything more complex. The code, the rollouts, everything makes more complex. So we're trying to be more simpler how we approach this. But this is a key part of our game. We A/B test. If it gets approved, then we put it in the game. And yeah, one thing that we push a lot is to make the decision fast. As in, if it's obvious that this A/B test is a good one, then okay, let's put it in the game, let's remove all the complexity in the code, and let's keep going. Or if it's obvious that this is not working, okay, let's analyze, but then let's remove it from the code base, and that way we try to maintain a more simpler code base. So yeah, this is more or less the talk. To wrap up, there's a lot of things that we did today, but yeah, basically a profiling plan. It's quite important in order to maintain a live operation. Yeah, if you want to extend the Unity profiler, you have an example here of how you can do that. If, of course, you deem necessary, it's not a condition to do this. Of course, always try to monitor the KPIs that you feel that is important for your game, and get the data and try to actually have a way to compare between versions. Yeah, it's always good, the stability of the game. So ANRs are really bad. So it's nice to always keep focus on that. And yeah, for us at least, experiment and chip faster is the way to go. Fail fast and move forward, iterate. And this is more or less how we profile a live game. So yeah, I mean, this is more or less it. No more to say than thank you very much. And if you have any questions, yeah.